In this problem, we're working with linear functions, and we see several questions written in terms of function notation. And so the key to these problems will be to first think about what the question's asking in terms of the lines that are underneath these functions, and then answer the question using the ideas that we already know. So for example, in part A, it says solve f of x equals 0. So there are really two issues here. One is that you could just follow this literally. We're asked to solve f of x equals 0, and we're told that f of x equals this. And so if you combine those two things, then this is really the same thing as just saying solve 8x minus 11 equals 0. And if you do that, you'll get, you're going to add 11 to both sides and divide both sides by 8. So you'll get x is 11/8. So it's a fairly straightforward thing to do. If we think about this in terms of the underlying graph is a line. Remember, when you see f of x, what you should think about is a y-coordinate on the graph of f. And so this is asking, where is the y-coordinate on f equal to 0? The y-coordinate on f equals 0 when you find the x-intercept. So the x-intercept is the point where the y-coordinate is equal to 0. And so we already solved this, but we can interpret this as saying that the point 11/8 comma 0, in other words, the point that has x-coordinate 11/8 and y-coordinate 0, is the x-intercept of the graph of f of x equals 8x minus 11. So if we think about that second idea, then part B is asking where's the y-coordinate positive, so greater than 0. So in other words, I want to give you I want to describe the x's where we have a y-coordinate of 0. So 11/8 is not such an x because it's y-coordinate greater than 0. But the y-coordinate here is equal to 0. So the question is, when I put in values of x bigger than 11/8, do I get y-coordinates bigger than 0? Or should I put in values of x less than 11/8 to see if I get values of y greater than 0? It's got to have something to do with this cutoff point, this 11/8, because you can't have your y-coordinates changing from less than 0 to greater than 0 unless they're actually equal to 0 at the transition. And the only place that we have a y-coordinate equal to 0 is at this point right here. So this has got to be the transition point, only possible transition point for this answer. So I could just test an x-coordinate that's less than 11/8. So let's try f of 1. 1 is less than 11/8. F of 1 is 8 minus 11, using the formula for f, which is negative 3. So when the x-coordinate is 1, that is when the x-coordinate is less than 11/8, my y-coordinate is negative. So now I'll test something bigger than 11/8, like 2. So 2 is a number bigger than 11/8, and f of 2 is 8 times 2, 16, minus 11 equals positive 5. So what I'm finding from my sampling here is that a number bigger than 11/8 for x gives me a y-coordinate that's positive, and an x-coordinate that's less than 11/8 gives me a y-coordinate that's negative. And again, 11/8 is the only possible transition point, so I conclude that all x's greater than 11/8 will have a y-coordinate greater than 0. If I want to write that as an interval, I would say I want everything between 11/8 and infinity, and I do not want to include the 11/8, so I use a rounded bracket there. Remember, including the 11/8 would mean that I would be using 11/8 as part of my answer, but when x was 11/8, the y-coordinate is 0, not greater than 0. So that would be my answer as interval notation, and this is my answer just described in words. So the same thing's going to happen for part C. We're going to find where these two things are equal, and then we can do this sort of testing thing to figure out which order they're in, because again, the only transition point between one thing being less than or equal to the other has got to be when they're actually equal. So, so C will lead to D in the same way that A led to B here. But I'm going to go to the next page to answer C and D. So again, in part C, we can just answer this just by substitution without really giving it a lot of thought. It's asking how f of x and g of x could be equal, and we're given an expression that's equal to f of x and an expression that's equal to g of x. And so if I just substitute, change f of x into what f of x is equal to, and then change g of x into what g of x is equal to, then I can make this look like just a generic algebraic expression. So I could say that solving f of x equals g of x is the same thing as saying solve this equation. So here I'll add 5x to both sides, and then on the left side I'll get 13x. And if I add 11 to both sides, then on the right side I get 13, and so I'll end up with x equals 1. Now, in terms of the graph, again, this is asking, is there an x-coordinate, so the y-coordinate of f, is equal to the y-coordinate of g? And the answer is yes. When the x-coordinate is 1, then the y-coordinate of the f graph is the same as the y-coordinate of the g graph. And so that means that x equals 1 is actually the value of x where we'd have a point of intersection of the graphs. So from a graphical point of view, the graphs intersect at x equals 1. And we don't actually know what that y-coordinate is at this point. I would have to plug in 1 and for x to the f or g formula to find out. But I'm absolutely sure that the y-coordinates will be equal then. So let's just do that real quick. F of 1 will tell us the y-coordinate of f when x equals 1. And if you put 1 in for f, you'll get 8 minus 11, which is negative 3. And if you plug 1 in for x in the g formula, you're going to get the y-coordinate of the g graph. Putting 1 in for x here gives us negative 5 plus 2, which is also negative 3. So the intersection point of the graph is actually x-coordinate 1, y-coordinate negative 3. And that'll come in handy for part E if you were to do that problem. That would be the point where the two lines cross. So we're not going to do that one in this video. Part D asks about knowing where these guys, where the f y-coordinates are less than or equal to the g y-coordinates. And so that's all that's asking in terms of the graph. But all I have to do is do my sampling like I did in the previous problem. Let me give myself a number line if I can see it. So this is a little bit of an easier way to be methodical about this. At x equals 1, I know that the f graph the value of f of x, well, let me erase that real quick and give myself enough room above this, so let me write my numbers above it. So when x equals 1, f of x equals negative 3 and g of x equals negative 3. So I'm just going to write those there, just making a little table. A number to the left of 1 would be x equals 0. You can use any number you want to the left of 1. F of 0 is negative 11, and g of 0 is 2. So out here at x equals 0, I know that f of 0 is smaller than g of 0. So that's how those are related to each other when x equals 0. The f graph's y-coordinate is negative 11, the g graph's y-coordinate is 2, so the f graph has the smaller of the y-coordinates. So now I pick a value over here, use 2. F of 2 is going to be 16 minus 11, which is 5. And g of 2 is negative 10 plus 2, which is negative 8. And so I can see here that f of 2 is greater than g of 2. And so, and of course here they're equal. That was the point of, I won't try to squeeze in the x and y there, but that was the whole point of part C, is that at this point the two things are equal. So at x equals 1, that's the transition point from values to the left where the f graph has smaller y-coordinates. And over here, when x is bigger than 1, you have points where the f graph has bigger y-coordinates than the g graph. And so, since this is the only transition point, according to C, this is the only place where these two roles can change. Because to change from f being smaller to f being bigger, we have to have some point where f and g are equal. So this is the only transition point there could be, and so over on this side, remember what we're trying to find is where are the f's, where fy coordinates less than or equal to the gy coordinates. It's going to happen everything to the left of x equals 1 is going to have that property. So I could say it in words. I could say every x that's less than or equal to 1. Notice I'm including equal here because I'm including equal as a possibility here. So when x is equal to 1, f and g have equal y-coordinates. Or, in interval notation, I would say it's everything between minus infinity and 1. And this time I'm going to include the 1 and indicate that with a square bracket.